Lesson 17.5 is finding area with a calculator. I find these fun. Once you figure out what you're doing, they all kind of become the same thing. And again, you're doing it on your calculator. But to find area of any bounded region, we're going to integrate the function. And we're going to go from A to B, so an x value to an x value. And those x values are going to be the points of intersection or whatever the bounds are of the shaded area we're trying to find. And it's always going to go top function minus bottom function d of x. So number 1 says, let R be the region bounded by the functions f of x equals 2x squared minus 9 and g of x equals negative 3x plus 2, shown in the diagram below. Find the area of the region R using calculator, round to the nearest thousandth. So what we need to figure out is, what is this x value? So we're going here to what is this x value? Because that is where our shaded region lies. So I've already went ahead and put in my y1 and my y2. I need to make sure my window's set, so I'm just going to go zoom 6, and that'll take it back to negative 10 to 10. So there's line 1, there's line 2. Okay, I need to zoom out a little bit. What you can do is zoom and hit 0, because option 0 is fit. Let's see what that looks like. So I hit 0. Just need to be able to see the 2 points of intersection. Okay, so here and here. I'm going to go second calc, intersect. It is kind of hard to see here. I'm going to go up until I'm above it. Okay, so I can see I'm on the 2x squared minus 9 line. Then the next one automatically puts me on the second line. Hit enter and then enter one more time. So that point of intersection there is x equals negative 3.212214. Would not round. Okay, let's do it again for the other one. This is x equals 1.712214. Okay, so that immediately makes my integral bounds be from here to here, because you want to go small to big. And then we want to take top function minus bottom. And the reason is, it's kind of like when you find area of shapes. Something I can think about is us doing in like pre-algebra and algebra is, say we want to find the area of, they call it like a frame. You would want to find area of the whole rectangle and then subtract away the area of the inside. It's kind of that same concept, but we have lines. So we want to take all the area under this linear function, which would be all of this, and then subtract away the area under the quadratic function, which would be all of this. What that leaves us with is just the shaded boundary. So that is why it becomes a subtraction problem. Okay, so I'm going to put this first line, which is my g of x minus f of x. You have to know that this was linear, this was quadratic, so which one's which. And then this is with respect to x. Okay, so second quit out of that, go math. Remember, 9 is an integral. You got to type in these numbers for your lower and upper bounds. Then you got to be very careful. You want to do g of x, which if I go back to y equals, my linear one, g of x, was actually my y2. If you wanted to put them in as a different order, that's fine. But when I'm doing this, I need to make sure, oh goodness, now I got arrow all the way over. I need to make sure that I'm going vars, y vars, function, selecting y2 first, minus, that's a pain. If you get out of this, then you got to go back to it. Okay. And then with respect to x. And that actually tells us just the area of region R. So it'd be 0.806. Pretty cool, isn't it? The other thing you could do, if you didn't even want to do this, you could simply do the negative 3x plus 2 minus 2x squared minus 9, and then simplify. You distribute a negative, so that'd be a negative 2x squared. That would be negative 3x, and then 2 plus 9 is 11. So you could also do your bounds, and then in here do your function that you get once you simplify. And you would get the same area. So it's kind of up to you. All right, let's try another one. Number 2, we've got a new shaded region. We've got an f of x function. It's quadratic, so that's this one. That's my f of x. And then g of x is my linear, this one. And then it also says the line x equals 0, which is a vertical line going through x is 0. Find the area of the shaded region using a calculator, round to the nearest thousandth. So our bounds, our x values that are bounding this, we've got x equals 0, they tell us that. And then we've got to find this point of intersection here. So you need to put your functions in and find that intersection x value. In mine, I did not change the window, so I'm actually going to go zoom 0 for zoom to fit. Let's see what that does. Still kind of don't like that. I might even go back to just standard, see if I can see that in the standard window. Okay, so that's the point that I want. And that should be x equals 1.36019909. Okay, and I want to go top minus bottom, so that is f of x minus g of x. So again, I'm going to do math 9. I like to do the y1 minus y2. But again, you could go ahead and do literally this minus this and simplify and put that in. So 0. And I get 2.199. So not much area because that's a pretty small region. All right, and number 3, we've got another f of x, g of x function, and the x and y axes. So we can see here and here are bounded. Find the area of the shaded region using a calculator. What's different about this one is that once I find this point of intersection here, if I were to drop down that x value, look how that creates actually 2 different shapes. So this region right here is going to be created between x is 0 and whatever x value this is. And then it's going to be this linear functions on top. And then it's just minus really y is 0, which we don't need to do. So I don't even use the quadratic one. It's just going to be the area under this line here, and that's g of x dx. And then I'm going to add to that area this second region. So I'm going to put area 1, and then this area 2 is going to be from whatever this x value is to whatever this x value is. And then this time I'm finding the area just under the quadratic one, which is my f of x dx. So it's just 2 separate integrals. So let's go ahead and put those in. Graph it. Go ahead and find this point of intersection here, the x value, and then find this x-intercept, or 0. Okay, you should have gotten this x value to be right here, the point of intersection. So that then creates from here to here, which is my 0, should have gotten that number. Now I'm going to quit out of that, go math 9, and I just type this in, and I remember that g of x has to go first. That's going to be my y2, and then f of x goes second in a row. That's y1. And when I put that all in, I end up getting a total area of 13.117. And really these, since they're so simple, you literally could have just put in here instead of y2 the 0.75x plus 4, and here this quadratic function might have been faster.